we are getting back to functions, and in grade 12 we are adding the inverse functions. So first of all, you've been doing functions from grade 9 when you did the straight line. First of all, what is a function? And this question is often asked for 1 or 2 marks. Is something a function or is something not a function? So in this case, a function is a relationship for which every x coordinate has only one y coordinate. Okay, I'm talking about it here, the vertical line test. So if I take a ruler and I want to do the vertical line test, it means that when I go through straight line, is everybody happy with that? Parabola, hyperbola, exponential graph, the 4 ones that you've got in your bag, in your tool bag so long, are all of them functions. So when I go across them like this, does it cut through that straight line at any space in 2 times? In other words, for this specific x, there's only one y. For this specific x, there's only one y. The same with the parabola. Every single place that I cut, it only cuts once. So in other words, that specific x has only one specific y. Same with the hyperbola. Never ever do I cut twice. And the same with the exponential one. It's always one x for one y. So let's look at what's not a function. If I look at this thing and we're going to see stuff like that, is this a function? Why not? Look at the vertical line test. For this specific x, it's got 2 y's. For this specific x, this one's got 3. So that's the difference between a function or not a function. Does it cut with only one x for every y, or is there more than one? And we'll just define that now. Okay, let's redo that again. For a function, when you do the vertical line test, it means that every time I cut through this red line, or this red parabola, or this red hyperbola, whenever I cut through it horizontally, for every x there's only going to be one y. In other words, it's only going to cut through the graph once at a time. So if I do go there, for this x there'll only be that one y. For this x there'll only be that one y. But in this case, which are inverses of cubic graphs and inverses of parabolas, when I do that, I'm going to cut more than one place. Sometimes, because if that's a turning point, how many, for that specific x, there's only one y. For that sideways turning point, there's only for that x one y. And then the same for this thing. You can see that most of the time it cuts 3 times. If it's on that turning point, it'll cut twice, there and there. So for this x, I'll have one y, 2 y's. For that one there, on the turning point there again, I'll have one y and another y. So if it cuts twice, it's not a function. Now you're never going to write vertical line test in the test. I'm going to ask you, is this thing a function? Is this thing a function, P and M? No. P and M are not functions. And my reason will always be the following little recipe wording. Because for every x, and you don't have to say coordinate, for every x, there is not just one y. We're not going to say more than one, because it's not always more than one. I showed you there, that specific one has only got one y. But for most of them, it's got more than. So you just say, for a function, every x has just one y. For a function, every x has just one y. Only just one specific y. But for a not function, every x does not have just one. So I'm including it. Some of them has one, but every x does not just have one y. Then it's not a function. Guys, they're definitely asking you that either June prelims, final exam, somewhere there's going to be a thing is this a function? Then your answer is either going to be, yes, it is a function because every x has one y, Or no, it's not, because for every x there is not just one. Nothing else. Not just one. That's it. You are doing the vertical line test just to help you, but seeing that for every x is there not just the one. Y. Now the ones that are added for this year, which we are going to start looking at now, is the log function. Now the log function is the inverse of the exponential one. And I'm going to tell you what an inverse is just now. So when I've sketched it, will it still be a function? Am I right in saying it's a log function? Why is it a function?
For every x,
When I do the vertical line test, it's sharp. When we get to this in April, May, when we're doing cubic graphs, is it going to be a function? Is it true that the cubic graph is a cubic function?
Yes.
Yes, for every x there's only one.
Wow.
So at the end of all of this, in a test, we are going to be testing you on 6 functions, which are the straight line, the parabola, the hyperbola, the exponential, the log, and the cubic graphs. Right. First of all, we're doing the straight line and looking at the straight line's inverse. Then I'm going to tell you what is an inverse. First of all, just revision. Oh man, I've done this in grade 9. Sketch this straight line for me. What do I need?
X and y intercepts.
The x and y intercepts. How do I get the x and y intercepts? For the y intercept, you make x equal to 0, and that's the case for all of it. Parabola, hyperbola, what's everything, logs that you don't even know yet, but you're going to make x 0 for y intercept, y equal to 0 for x intercept, always. But the y intercept I could also see, right? Because I know y equal to mx plus c is always my y intercept. So I could just say that c is fine. Or if you forgot, substitute the x with 0, it's still fine. For the x intercept, we say y equals to 0, and we solve a little linear equation. What do I do with linear equations? Get the x to one side, numbers to the other side, so it's 5 over 2 or 2 and a half. When can I sketch that?
The following learner should please come to Mr. McLeod's office, table in grade 9. Come.
So I'm able to sketch this graph. How do I sketch it? X-intercept 2.5, y-intercept 5. And I don't go measure, but I'm just trying to make this look a little bit less than that at least. You with me? But it's not an accurate graph. It's a sketch graph. So that graph represents G. Let's go through, there's not a lot of stuff to go through with this straight line. All I might have asked you was, and it's a silly question, what is the, it was called G, right? What is the domain of G?
What is it all the way?
What is domain again?
It's all the
X's. What X's have I used for that graph?
2.5.
Domain. Goes from where to where?
Oh, it's the element of all real numbers.
All the numbers.
Yes.
Not just 2 of them.
Oh, no.
All the numbers, because it goes into infinity and infinity. And why? The range. Same thing. Unless I gave you some sort of a restriction, then there would be less than them. Silly question for an exam, do you agree?
Yes.
But if I asked it, all of you were caught out just now. It's so easy that you've forgotten about it. All right. Things like maximums and minimums don't apply for straight line, which is a silly question to ask. Asymptotes, there's nothing. Axis of symmetry, by the way, for a straight line. Is there one?
No. There's no essence. There's no essence. There's no, what's that?
Think about it. What is an axis of symmetry?
It's when it cuts.
This is my axis of symmetry. Same here, same there. Straight line?
No. There used to be an essence.
There's one. Look at it reflecting. Even there. No, you're saying no, ma'am, it's too short. But remember, It goes on until infinity. So technically, how many axes of symmetry does the straight line have?
Infinity.
Infinity. So it would be a stupid question to ask, but I'm just saying, if I should have an axis of symmetry, we would want to put it right there in the middle to see it reflecting. But it doesn't matter if I put it there, because it's still reflecting from infinity to infinity. Are you with me? Technically. Now let's get into what an inverse is. Inverses means that you swap the x and the y. Very mathematically put. So if I want to get the inverse of g, I'm going to say it's not, what is this again? Y equals negative 2x plus 5. I'm going to say it is?
X equals to negative 2y plus 1.
That's where your first mark will go, because you know that you must swap them around. So an inverse is when you swap the x and the y's around, now that you know it. Will I ever leave this inverse, this new thing popping out here, will I leave it in this form? How do we always write any function or any representation on a graph? Y equals. So can we fix that? Yes, obviously. 2y is equal to negative x plus 5. Are you with me? And then we divide. Now I'd rather want to write it that way, just for personal preference, but I could have just said minus x over 2. But if I write it this way, I can immediately see what is M? Gradient is. Are you with me? And now this is now the equation for g. So I wouldn't leave it that way. And since it's now equal to y, I can say g, but g has now got an inverse, so it's not gx anymore. It is with a little minus 1 there at the top. It's a new notation. So when I speak about f and f minus 1, I'm talking about a graph and its inverse. You must know what the notation is about. So that will be the inverse then of the straight line. Now, please sketch this inverse for me. What's going to happen? I'm going to go find the x-intercept and the y-intercept. You don't have to, please don't. All you need to go do is swap the x's and the y's around. So let's make this blue. So for my inverse graph, this is very skewed. My y-intercept that was 5 is now going to be my x-intercept that is 5. For my blue graph, my any1, this was the x-intercept, it's now going to be the y-intercept at 2.5. Have you got a graph?
Yes.
So everything swaps. If I give you 6 different points on whatever graph, all you need to do is take those points and swap them around. So this one was actually 2.5, 0. What has it become? 0, 2.5. Do you see it? What happened? X and y swapped. This one used to be 0 and 5. Now it's become 5 and 0. X has become the y and the y has become the x. Let's sketch that. And we have g minus 1, the inverse, where we have g. Are you with me, everybody? That's it, inverse. Could I have gone and said, well, find the x-intercept by putting y equal to 0, find the y-intercept by putting x equal to 0? Obviously you can, but this is just so fast. Once you know what you're doing, that you're swapping x and y around. Right. What else would be changing? Now, the domain won't be x is element of r, but this is a stupid example because it's going to look the same. But actually what's happening is the range becomes y element of r. So we have all the x's and y's swapping around. Even for this one then, the domain of g minus 1 will still be. But it's actually the other one's x's and the other one's y's. But it's not going to make a difference here. The domain and the range of g minus 1 will stay what it was, basically. Another one important thing. is that these two graphs will be mirror images of each other around the line. Let's make it black. Around the line that goes in the middle of these two quadrants. Right in the middle. Right in the middle. Can you see it? Mirror imaging. It's a reflection around this line. What is this line? What is the equation of this line? Y equals? Mx plus c, but what is this line then? Not negative x, it's positive. I want the equation. You just have to give it to me.
Y equals x plus c. Y equals to x plus c.
So what's m?
There's no.
1.
We know it's the gradient, guys. Come
M
on.
is 1. Because it's smack in the middle, and you've done it when you did the axis of symmetry in the hyperbola. When it goes right there in the middle, the gradient is 1. Let's look at it another way. It's a straight line, right? And all of these points, if it's going to be smack in the middle, if this x is minus 1, then what's the y going to be?
1.
Minus 1. If this x is minus 5, y is minus 5. So y is equal to? That's the equation that you are always going to use for the axis of symmetry. This is a line of reflection. So G and its inverse will be reflections about the line. Which line? And this will always be the case. When we go to the parabola now, when we go to the hyperbola, when we go to wherever, they have to be reflected around this line. This black line that I put in here, it will be reflected. Do you see it reflecting?
Yes.
Can you see this red line's reflection is that blue line's reflection? Can you see that this blue reflection there is the red one? Although this is not accurately sketched, you can see it happening, right? And it will be the case always. So if I ask you in a test, parabola, hyperbola, whatever, what is the reflection line of F and G? Which is the graph, ma'am? I don't know. Which is going to be the reflection line of the F and the inverse?
Y equals to x.
Always. Always. I don't even have to know what the graph is, but it has to reflect about this line. Always. I forgot to say that a line is always a function because of the vertical line test, right? So if you go back to the sketch that's not here anymore, whether it was the red line or whether it was the blue line, they're both lines. So I'm saying that line G and its inverse, which is also a line, are both functions. Why are they both functions?
Because every x
Every x
has
has
only one
Every x has only one.
One.
Why? That's why it is a
function. What is engagement?
Okay, let's get into the parabola and its inverse. What is the inverse? When you swap all the x's and the y's. We found also the equation of that inverse. We're going to do it with this one as well. Right, let's see. First of all, will you be able to sketch it? I hope so. How do we sketch a parabola, please?
Find x and y intercept.
X and y intercept, definitely.
And then
I
two
like it
points.
if you know that it's going to look like this, because if that's all you did in your test in exam November, and on your sketch you've got something like that, you've got a mark.
Ah,
Because they're giving you a mark for the shape, for knowing that it's a
parabola.
positive parabola. Okay, so if you've done it there at the top, maybe you have a mark. On a graph, positive. Then you said we want the y-intercept and the x-intercept. Y-intercept? Again with the c. Because if it's in this form, ax squared plus bx plus c, c is always the y-intercept. Remember that if I asked it to be sketched and it was in turning point format, you could see the turning point, but you can't see the y-intercept, and you actually have to go work it out. Alright? For the x-intercept, we're going back way back here, right? Here with all the stuff that you should know. You put y equal to 0, so it's 0 equal to x squared minus 4x plus 3, and this is where your fantastic calculator comes in, although this wasn't so difficult to factorize. But we're putting into our calculator a is 1, b is negative 4, c is 3 to get to our x-intercept. And your calculator will then tell you that x was equal to, what is it? 1? And not n? Alright? Always or. This is not acceptable. You have to show me the factors. Going back from here, it's x minus 1 and it's x minus 3. Or you had to factorize or you had to use the formula. The formula takes too long to do it everywhere. So I've got two x-intercepts. Can I start sketching? Well, not quite, but we can. If that's all that you have, then please sketch it. You might get a mark or 2. So my x-intercept is 1 and 3. Again, it's a sketch graph. It's not accurate, but at least I want it to be approximately, not 1 and 3, something like that. And my y-intercept is 3 again. So I'm going to try and make it look nice, like almost the same. Then I've got to still find the
Turning point.
So at least if you got this, and you didn't know how to find the turning point, and you make sure that it goes through there, I don't know where the turning point is, you're going to lose a mark for the turning point, but there's some marks, right? Hopefully the turning point's not a problem to you. For the turning point, how do I find it?
Minus b over 2a.
Is that the only way of finding it?
No.
Obviously not if I'm asking. There's always alternatives. If you know it must turn between there, where must it turn? At 2. Has to be. Because it's got to be symmetrical. Has to be. Okay? So if you just said it was 2, I'm happy. Not even with the b. Where did you find it? Because of symmetry. I would like you then to say, because of symmetry. So that the person marking knows that you didn't watch it on the guy next to you. Okay? Now let's see if we do go for the formula. We're putting it in. It's going to be minus b, so it's minus of minus 4 over 2 times a, which is 1. So it's plus 4 over 2, which gives you, amazingly, it's 2. Then the y value, because that you can't guess. You know that it's going to be somewhere here by the minuses, but minus what, I don't know. You can't know that. You've got to work it out. For every x there's a y, for every y there's an x. So fill in the x's place, the 2, and your answer is minus 1. Sounds correct. So that my turning point is 2 and negative 1. So on my graph, 2 and minus 1. And I have a parabola. And the parabola's name is?
F.
F. Okay, so guess what we're going to be doing now? Same thing. Before we get into the inverse, let's do a few things. How about the domain?
Because x is the element of.
Yes, I agree. X is all the real numbers because the x's go from everywhere to everywhere. But the y does not.
It's y cannot be
Y must be
smaller than negative 1.
greater
Oh, yes, greater.
than negative 1. Just greater or equal. It's important. You're not going to get the mark if it's not greater and equal. It's including minus 1 and everything bigger. So that's going to be the domain. Right? What is your maximum value? No, man, there's no maximum value. There's a minimum value of negative 1. All these funky things that we could have asked. Axis of symmetry. Is the line cutting there through the turning point? What is the form? What is the equation?
Y.
X is equal to? It's actually here. X is equal to? It's part of the turning point formula. Has to be, right? Asymptotes. No, there's nothing there. I'm busy with a parabola. There's no asymptotes. What else is there that I can ask you? was it
The
that I wanted?
inequalities that you
Now, before we even touch the inverse, tell me what will be the inverse? Changing. So this was F's domain. Then the range of F's inverse will be what?
Why is it element of real numbers?
You don't even know what it looks like yet. I'm showing you what's going to change. All the X stuff is going to be Y stuff, and all the Y stuff is going to be X. So for the range, it used to be, and now it's going to be the domain of the inverse. That's going to be what?
X.
X bigger or equal to negative 1. Are you starting to feel the picture here? Then this minimum won't make sense either in this sum. I won't ask it for you because this graph is going to go like this. So to ask you for a minimum value, minimum and maximums are always about the y. Right? Going more or lesser or everywhere. But you can't talk about a minimum and a maximum here. Are you with me? So that's out. Axis of symmetry, will it have one?
Y equals to 2.
It's going to go like this. Y equals always is a horizontal line. X equals is always a vertical line. It's coming back to you. Axis of symmetry will then be Y is equal to 2. Alright. Now we need to go into the sketch of this graph. So please sketch it for me. Shouldn't we get the formula first? I'm going to leave that for
Turning
last.
point.
Because the moment that you have the original graph, how do you sketch its inverse? Swap everything around. So in purple, we're going to do the inverse. So this was a y-intercept 0, 3. Now it's going to be an x-intercept 3, 0. So my purple graph is going to go exactly through there. Okay? The x-intercepts were 1 and 3. So the y-intercept should be 1
And 3.
and 3. So it's going to go through there as well, and it doesn't always have to be. What is going on here?
Yeah.
Can you sketch this so long?
No.
Because you need something else as well.
Turning point.
The turning point that used to be 2 and minus 1.
Will be minus 1.
Where's minus 1 and 2?
Then
Are you with me? Now remember, it's not a sketch, it's not an accurate graph, it is a sketch graph. But minus 1, I'm trying to get it similar, and 2 is not there.
it's in the middle.
It has to be there. Are you with me? It is a sketch graph, but with a little bit of logic in there as well. So this point is the point negative 1 and 2. So every single point, 0, 3, 3, 0. 1, 0, 0, 1. 2 and minus 1, minus 1 and 2. Everything swapped. Now remember what we had in the straight line? We had that black line going, right? That black line, which name was? Y equal to x. It's got to be here. And these two graphs must make a mirror image of each other, reflect about it. So let's see, if I sketch that, you see it going?
Yeah.
Where? Right? And over here? This one's going a bit flat here. Okay? Can we do that black line again? It should go through there so that they can reflect, right? This one is a little bit skewed, so if it had been more accurate, you would have seen it better. And it goes through there as well. It has to go through those 2 points so that it can reflect. You see this little piece here reflecting? Even over here, reflecting each other. Let's look at these little pieces here, reflecting each other. You see it? And this line is still y equal to x. Quick, exam paper. What is the equation of the line of reflection of, what is this, f and f minus 1?
Y equals to x.
What is the reflection of f and f minus 1? What is the reflection of f and f minus 1? Line x, y is equal to x.